Chapter 7, Similar Polygons. Today we're going to cover Section 7.5, Day 2. Your class opener. Are the following triangles similar? If so, name the similar triangles and the theorem or postulate used. So name the two similar triangles, also name the theorem or postulate that justifies your answer. So as I go through these, I'm always thinking, I'm either looking for angle-angle similarity, side-angle-side similarity, or side-side similarity. So number one, they don't give me any angles whatsoever, so my choice is sort of looking for side. I'm going to just set up one big proportion. I'm going to pick the all values from one triangle and put them all on the top, and I'm going to write them from smallest to largest. So it would be 18, 24, 30. Now I'm going to pick the three values from the other triangle, put those three on the bottom, and also write them from smallest to largest. So I have 9, 12, and 15. And let's check and see if they all reduce to the same value. So 18 over 9 is going to reduce to 2 over 1. 24 over 12 reduces to 2 over 1. And 30 over 15 also reduces to 2 over 1. So they all reduce to the same value. So everything is proportional. So I do get my triangles similar. So I'm going to name it as triangle FDE is similar to triangle. And now you have to figure out, how are you going to name the other one? So to me, the easiest way to look at how do you name them is if I picked FD. Okay, well, F and D was 18, and 18 matched up over here to the 9. So where's the 9 coming from? Well, the 9 is coming from the BC. But I don't know if I should write BC or CB. So then I'm going to look at what would have come next. So next would have been DE. Well, for me, DE was 24, which matched up with the 12, and 12 was coming over here. So if I match this up in the same fashion, it's going to be B, C, and then A. So I have my triangles in the same naming order, and this all happened by side similarity. Number 2. Looking at this one, I notice they share angle C, and I have the sides that make up angle C. So in my mind, I'm thinking that this is probably going to be side similarity. Now, checking the sides, the one triangle, the sides are going to be 3 and 5. My other triangle is going to be these longer pieces, which I'm really going to be looking at 9 and then 15. So let's set up a proportion and see if it works out. So if I pick the values from the yellow pieces, I would get 3 and 5. Then the larger triangle with the blue markings would be 9 and 15. And let's see if they reduce to the same thing. 3 over 9 reduces to a third. 5 over 15 also reduces to a third. So they are in the same proportion. They share the same angle. So I get that triangle, and I'm going to call it CDE. It is going to be similar to, and then naming the other one is going to be CAB. And we already said that this was going to be by side similarity. Number 3. I have parallel lines, and I know parallel lines give me corresponding angles congruent. And as soon as I get two angles, I already say that the triangles are congruent by angle-angle similarity. So I know the angle-angle similarity, and now just naming the triangles. So I'm going to call one of them triangle EAC. And it's going to be similar to, and EAC will match up to DBC. Number 4, proof. Given that JL over NL equals KL over ML, prove that angle J is congruent to angle N. I know I have my two columns. I'm going to copy down my given information. And trying to think of a game plan. They're telling me that sides are proportional, and let me even mark where the sides are. So I have JL and KL are in the top of the proportion, and let's see, NL and ML are in the bottom of the proportion. I notice that vertical angles are congruent, so I can get triangles that are similar to each other. And if I look at my proof statement, I know that if the triangles are similar, all the angles are going to be congruent to one another. So my big thought is, let's say that the triangles are going to be congruent by, or similar by, side angle, side similarity, and then I can get my final proof statement of the angles are congruent. So if I want to use side angle side, I already have the sides are proportional. I need that the angle is congruent. So up on the top, I get angle JLK is congruent to angle NLM. And the reason is vertical angles are congruent. And now I can state that the triangles are similar to each other. So up on the top I get triangle JLK and JLK is going to be similar to NLM. And we know that our reason is side angle side similarity. And now if the triangles are similar, all the angles should be congruent. So I can get that angle J is congruent to angle N. And my reason, if triangles are similar, then corresponding angles are congruent. And your closure. Find something that you learned today that is similar to something you already knew. Write about these similarities.